Hello everyone, this is Deepak Kumar, Assistant Professor in Kite Group of Institution. In today's session, we will discuss the concept of queue and its implementation using an array. These are the content of today's session. The very first one is queue basic, where we discuss the basic of queue. Next, the representation of queue using an array, and then we will discuss the different queue operations. So now we will start with the basics of queue. So queue is nothing but queue is linear data structure, just like array, linked list and stack. If we are comparing queue using and stack, so in stack we have only one end where we perform insertion as well as deletion operation in stack, but in queue we have two ends. From one end we perform insertion and from another end we perform deletion operation. So let's suppose, consider it as queue where we have two ends, front as well as rear. So from rear we just perform NQ operation. NQ is nothing but it is basically an insertion in queue. Similarly, DQ is basically a deletion from a queue. So we just perform insertion from one end and deletion from another end. So the end from where we perform insertion is known as rear, and the end where we perform deletion is known as front end. Okay, so always in queue the insertion is performed from rear end and deletion is performed from front end. This is also known as rear tail, and this is also known as head. Okay, the next concept of queue is that queue is worked on the principle of FIFO, that is first in first out, while stack is worked on the principle of LIFO, that is last in first out. Okay, so in queue it is not fixed that front is always here and rear is always here. You can change the position of these two variables. So there may be a possibility that rear will be here and front may be here, but always remember that the insertion will always perform from rear end, okay, and deletion is always performed from front end. That is the important concept in queue. So let's suppose if conceptually we just represent queue. So let's suppose this is a waiting line and this is the front end and this is the rear end. Whenever we want to add an element in a queue, then that element is always inserted from rear end. Okay, so let's suppose this is a new element and we want to insert it in a line. So this new element will be inserted from the rear end. Okay, similarly, when we want to remove an element, so the front element will be removed and the next element from the front element will be your new front element of the queue. So this is the way through which insertion and deletion operation is performed in a queue. So out of these operations, DQ and NQ is the basic operation of a queue that I earlier discussed with the help of conceptual view. Then we have another operations also in queue, that is the peek operation, where we just find out the front element of the queue. Next one is empty. This is basically used to check that queue is empty or not. Is full. In similar way it is used to check that queue is full or not. And display. Display is basically used to display the element of a queue. So these are the operations. Now we just represent each operations of queue using array representation. So now we will discuss the first one, that is enqueue operation. So when we implementing queue as an array, so we know that array is what? Array is static memory allocation. That means first of all we have to represent the size of an array, or we can say that the queue. Okay, so in this particular case, in this particular operation, first of all we define the size of an array, that is size of an queue, that is 5. Okay, here we use macro functionalities because this size will be considered as a global variable. Okay, next we just took an array where the name of the array is q and the size is n, that is 5. As we know that in q we have two n, that is front and rear. So here we just took two variable, front and rear, and initially the value of front and rear is equal to -1. So let's suppose we want to perform insert operation in this particular queue. Let's suppose we want to insert an element 3 in this particular queue. So the element will be passed in this particular function, that is we use void enqueue function. So whenever we want to insert an element, so first of all we have to check that the queue is full or not, because if the queue is full then we cannot insert new element in the particular queue. So how can you check that the queue is full or not? So here we have a condition when queue is full. So when the value of rear is equal to 4, that is n minus 1 if the size of array is n. So when the value of rear is equal to 4, that means queue is full. Why the value of rear? Because we know that whenever we perform insertion operation, so the insertion will perform from rear end. Okay, so that's why we check that rear is equal to 4 or not. Okay, so first of all we check that if rear equal to n minus 1, if this condition is true, then the queue is full. Then we check if the queue is empty or not. So when the queue is empty, when front and rear is pointing to this, that is -1. Okay, so when front and rear is equal to -1, then the queue is empty. And when this front and rear is -1 and we want to insert, then simply we just increase the value of front and rear by 1, that is front and rear is equal to 0. Okay, so in else condition we check front and rear equal to -1. Yes, if this is -1, that means the queue is empty. So we just put the value of front and rear as 0. Okay, so now front and rear is pointing to this index, that is index 0, and q of rear is equal to x. So rear is what? Rear is equal to 0. So q of rear is equal to x, that is 3. Okay, now we want to perform insert next element, that is 4. So again we check if rear equal to n minus 1. So in this particular case rear is equal to what? Rear is equal to 0. So rear is not equal to n minus 1. So this condition is false. Then we check front and rear equal to -1. No, right now front and rear is not equal to -1. So this condition is also false. Then we will move towards else block. So what we do in else block? In else block we perform rear plus. So initially the rear is equal to what? Rear equal to 0. Now what is the current value of rear? The current value of rear is 1. And in this particular index we just insert a new value, that is q of rear is equal to x. So q of rear is what? Rear is 1. Q of 1 is equal to 4. Okay, now we want to insert another element, that is 5. Then again we check all these conditions. Rear equal to n minus 1. No, right now rear is not equal to n minus 1. Then we check rear and front is equal to minus 1. No, this condition is false. So we will move towards else block, rear plus plus. So now the value of rear is equal to 2 and q of rear equal to x. So q of 2 is equal to 5. Okay. So in this way we perform insertion operation. So whenever we want to insert an element in the queue, then the complexity is order of 1, because only one operation is performed when we want to insert an element in a queue, that is rear plus plus. We just increase the value of rear and perform insert operation. Okay. So the order of 1 is the complexity of NQ operation. Next one is DQ operation. So let's suppose we have already 3 elements in the particular queue that we have inserted earlier, that is 3, 4 and 5. So the value of front is basically pointing to this index and rear is pointing to this index when we have 3 elements in a queue. Okay, and we want to delete an element from the queue. So always remember that the delete operation is always performed from front end. Okay, so what we do, first of all we have to check that the queue is empty or not. Because if the queue is empty, then we cannot perform delete operation. So first of all we check front and rear is equal to minus 1. If it is, then we simply flash a message that the queue is empty. Else we check that front is equal to rear. So when the front and rear is same, so when the queue have only one element, then this front and rear pointing to the same index. And in that particular case, when we deleting that element, then again queue will be empty. So let's suppose if in this particular queue only one element is there, that is 3. So when only one element, then front is pointing to this location and rear is also pointing to this memory location. And if we want to delete, if we want to perform DQ operation, then after deleting this value, again the queue will be empty. So what is the value of front and rear after delete operation? The value of front and rear will be minus 1. Okay, so if front equal to rear, that means only one element in the queue, then front equal to rear equal to minus 1. Okay, okay, else if we have 3 elements in this particular queue, then we are in this particular loop. Else printf, the deleted element from the queue is queue of front. So the deleted of element is 3, and what we perform, we simply increase the value of front, that is front plus plus. Now front is pointing to this memory location. So when front is pointing to this memory location, now this is your garbage value. Okay, because now this location is not identified. Okay, so in this way we just perform DQ operation in a queue. Again, if we want to perform DQ operation, so what we do, first of all we check that the queue is empty or not. If so, in this particular case the queue is not empty, then we check only one element is there, but right now we have 2 elements, so this front is not equal to rear, so this condition is also false. And then we just print this value and increase the value of front, that is front plus plus. Okay, so in this way the DQ operation is performed. The next one is display operation. Now we want to display all the elements of the queue. So now how can you display the elements of a queue? Let's suppose again we have 3 elements available in a queue. Front is pointing to this location and rear is pointing to this particular memory location. If we have 3 elements. Now we want to display these elements of the queue. Now what we do, first of all, we just take an integer variable I, okay, and check that the queue is empty or not, because if the queue is empty, then we cannot display any elements. So for checking, we use front is equal to -1 and rear equal to -1. If this condition is true, then the queue is empty. But in this particular case, queue is not empty because the queue have 3 elements. Then we will move towards else block, and for I is equal to front, what is the value of front? Front is equal to 0. So for I is equal to 0, I less than rear plus 1. What is the value of rear? Rear is equal to 2. So 2 plus 1 is what? 3. So I is less than 3. I plus plus. Okay. So what we do? For I is equal to front, I is less than rear plus 1, printf %d q of I. So first of all, q of I is what? I is 0. Then this 3 will be printed. Okay. Then I plus plus. Then the value of I is 1. 1 is less than rear plus 1, that is 3. Yes, condition is true. Then this 4 will be printed. Again I plus plus. I is equal to 2. 2 is less than rear plus 1, that is 3. Yes, 2 is less than 3, condition is true. Then this 5 will be printed. Again I plus plus. Now I is equal to 3. 3 is less than 3. No, the condition is false. Okay. So now this for loop will be terminated. So this is the way through which we can display the element of queue. Now we will discuss how can we find out the peak element of the queue. That means the very front element of the queue. So it's very simple. First of all, we check that the queue is empty or not, because if the queue is empty, then we cannot find out the front element. Then how can you find out the peak element? The peak element will be identified via variable front. Okay, so that is q of front. Q of front is what? 3. It's clear, because front is always pointing to the very first element of the queue. So whenever we want to find out the peak element, so we just print the %d q of front. Okay, so in this way we just find out the front element of the queue. So this is all about the implementation of queue using an array. In our next session, we will discuss the implementation of queue using linked list. Thank you so much.